Hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 15 of the June daily Leetcode challenge, and we again have a medium level question in front of us. And today's question answer is based on a tree. Okay, yesterday we saw a binary search tree, and we also saw what its in-order traversal is special about, what is the special thing about that, and we solved a question on that. Okay, and today we are again having a binary. It's not a binary search tree, but it's just a binary tree, and we are also going to see some properties of it. Okay, so it's question 1161, maximum level sum of a binary tree. Okay. So given the root of a binary tree, the level of its root is 1. Okay. So what is the meaning of this? I will come to that later, but let us fully understand the question first. Okay. The level of challenge 2, and so okay, let's ignore that first. Return the smallest level x such that the sum of all the values of the nodes at level x is maximal. Okay. Let's see the example. So what they're calling is the root is calling they're being it's being called level one. Okay. So there is only one element at the root, so its value will be the same. Okay. Now come to level two. That is the one. See, level means distance from root. Okay. So as the level increases, the distance from root will increase. Okay. So if level one is the root, obviously level two will be its children. Okay. So you can see 7 and 0, they are level 2. Okay. Similarly, 7 and minus 8 are level 3. Okay. So what they're saying is smallest level x such that sum. Okay, please highlight this word sum of all the values of the nodes at level x is maximal. Okay, so at level 1 sum is only one element present, so it's 1. Come to level 2 now. Okay, what are the level 2 elements? 7 and 0. What is their sum? It is 7. Okay, and what is the level 3? It's 7 and minus 8. What is their sum? Minus 1. Okay, now what they're asking, the smallest level x such that the sum of the values of nodes at level x is maximal. That is, I have to return the level with the maximal sum. Okay, I have to return the level with the maximal sum. If there are two such levels, the smallest one should be returned. Okay, please make this point very clear what we are doing for each level. Okay, level, I again repeat, see, these things are see, for study CS fundamentals, these things will be clear for you. Level is basically distance from root. Okay, the 7 and 0 are at a distance 1 from root. Similarly, 7 and minus 8 are distance 2 from root. Okay, so consider in that way. So whichever element have a distance 1 from root, you have to take the sum of all of them. Okay, that will be called the level sum of the level 1. Okay, now what we have to do is we have to find the maximal sum, and if two levels are having, or two or more levels are having the maximal sum, then you have to return the smallest of them. Okay, I hope my question is very clear to you, because I've tried my best to explain you. Okay, with each word I have explained what it means. Okay, so we return the level with the maximum sum, which is the level 2. Okay, so here it is. One important thing is the root level is called level 1. Okay, normally what I've seen in Leetcode is they will call it as a level 0, but here in this question they refer to it as level 1. Okay, that is the important point. Now coming to my approach. Okay, I will be using the DFS approach, and during the DFS traversal itself, I will be gathering all these sums. Okay, in each of the levels, and then we will be going through the sums and trying to find which is the maximum. Okay, let us see the approach now. I am declaring a dictionary called level sum. Okay, here the key will be the level number, and the value will be its level sum. Okay, that is the sum at that level. Okay, for example, the key value will be 2, and the value will be the sum of that level is 7. Okay, so it will show here. Okay, now I am declaring a defense function. This whole is a defense function. Okay, and this is the call to the defense function. Okay, so in defense function, what we are doing is it's very simple. First of all, there are two parameters here. First is the node to be explored. Okay, next is the level. Okay, when I'm writing code -1, I think these things should be clear by now. If you are a, if you have studied C plus and all, you will be knowing. So it's a default parameter. That means if no parameter is given, then this parameter will be used. Okay, otherwise the value passed will be used. Okay, as you can see in the first thing, I'm not passing any value. Okay, so if you want, okay, you can pass the value also, but since I'm not passing any value, so the default value will be taken. If a value is passed, then that value will be taken, which you're doing in the other part. Okay, so this is my defense function. Okay, I will go line by line in this. If the node is none, return. Okay, because if it is none, we don't want to explore it further, because child will be none, right? So just return it further. See, node which is none will not have any children node. Okay, so it's dot left dot right. If you do, it will come error. Okay, because none node will not have any value, will not have any left or right pointers, right? Now comes the very important part. Okay, if level, that is the level of this current node. Okay, level of this node. Okay, if level is already existing in the sum. Okay, let us come to the case where level is not existing. Okay, so what we'll do is in the level sum, I will make a index of this. Okay, that means it will be a new key now, and what will its value? It will its value will be the the value of the current node. Okay, the value of the current node. Okay. Now come to a case when the level already exists. Okay, for example, if we have created this for 7, okay, then for when we come to 0, this level will already exist, right? So this will already exist. What we'll do, we'll simply add the current node's value to the already existing value that is already existing sum of the previous nodes of that level. Okay, here you can see we are doing plus here. Okay, here we directly assigned, here we are doing a plus to the previous value. Okay, that is the basic idea. So what will happen is, see, first 7 will come, then when we are exploring 0, 0 will be added to 7. Okay, so it will become 7 plus 0. Okay, same will be the case here. 7 will be there first, then when we visit minus 8, it will be added to it. Okay, 7 plus minus 8 equal to minus 1. Okay, then I'm printing to show how it works. I will just quickly run and show you how it looks. Yeah, so level 1 sum is 1 because there is only one element. Okay, now comes level 2. Level 2 sum is 7. Then comes level 3. Level 3 sum is minus 1, as you can see here. Okay, so that was all about it. Okay, key is the level number, value is the sum, level sum. Okay, now we have to find, now this is the question, right? And now this is the question. We have to find the, first of all, we have to find the maximal sum. Then if two or more levels are given the same this maximal sum, we have to choose the smallest level. Okay, so what I'm doing is, I'm going through the level dot values. Okay, level dot values will give me all the values. Okay, see, there are key value pairs in level sum, right? I only want the values. Okay, because the value tells me the level sum at each of the levels. Okay, so I'm only going through the values and I'm taking the max of it. Okay, I'm taking the max of it. Okay, then I'm assigning it to max level sum. Okay, this is the most, the maximum possible level sum throughout all the levels. Okay, now I'm going to iterate over the level sum dictionary. Okay, this is how we do it. Level sum dot items. Okay, for I comma j and level sum dot items, what it means is I will represent its keys, j will represent its values. Okay, I'm checking if the value matches the maximum value, which I've extracted here. If the value matches, if the j matches the maximum value, that means I is the level for which this value came. Okay, so return I. Well, see, how I am. See, one thing you have to ensure is we have to return the smallest possible. Okay, so when we are doing that, it will always start from the smallest one. Okay, so I will be, for example, level 2 and level 7, let us say, have the highest value. So I need to return 2, right? How to ensure that? See, when we are exploring like that, obviously 2 will come first, 2 will come before 7, right? So in 2, when I find that it's having the maximum level sum, I'm returning 2. Okay, I'm not going for 7 after that. Okay. If you talk about the time complexity, see, the time complexity of DFS is O of n plus c. Okay, where n is the number of nodes, c is the number of edges. But in this case, if we consider only the nodes, it's around O of n only. Okay, often, and see, because I just, in this case, right, number of nodes, and if you see the number of edges, they're almost similar. Okay, so it's around often only. And if you consider this part, okay, this is for DFS, right? This is for DFS. Coming out of DFS, this is what we're doing, this is what we're doing, right? So this maximum value can be obtained using a O of n approach. Okay, again O of n approach. And if you come to this again is O of n approach. So total one will be around O of n only. And space complexity, basically, see, for each level we are just storing a sum. Okay, so uh, if the number of levels is L, okay, then the space complexity should be O of L. Okay, because for each level we are just storing a sum. So yeah, that should be all. See, there is basically a way to relate. Okay, see, for example, if you know the number of nodes in a given binary tree, you should be able to relate its height. Okay, so that also can be done. So because I'm taking L and saying, but basically there is a relation between L and L, right? Where L is the height of the given tree. Sorry, height means the normal levels of the given tree. Okay, that was what I wanted to say. So yeah, friend, that was my solution. If I want, I can run and show you. It basically clears all the test cases and passes the hidden test cases also. If you have a better solution, please do let me know. But remember, see, there are many ways to do it. But see, ultimately, you have to get the sum from each other level. You can do any way for that. Okay, either you can do BFS or DFS. Uh, but see, for me, DFS was more suitable here because we are maintaining the level of each of the nodes, right? So DFS was more suitable for me in this case. You could have done any approach, but this is something I think which will be remaining similar for your approach also. See, one thing is that I would have created an extra list where I would have copied the values from the level sum, and then I would have sorted it, and then yeah, I could have taken the first element, something like that. But see, if you talk about sorting, it takes, for example, a list of length, and if you sort it takes n log n, right? But if you just simply go through the list, it will take just go often. So that was my thinking, that instead of creating a new list, it will add to the space complexity. and sorting it, then getting the first element. It's better to like simply go through the list through often time complexity and get the maximum element, and then we can again go through it, and then get its level, that is its key, right, for the value, so the key for the value, right. So that was my approach. If you have a better approach, please do let me know, we can discuss it further. And yeah, friend, that was all for today. Again, see you tomorrow. And today is day 15, right? So congratulations to all those who have maintained their pace till now. So whenever I say maintain their pace, it means trying your best. It did not mean that you should have solved everything. Okay, it always means showing up, right? If you are showing up for the day's challenge, that means you have the guts to succeed, right? That's what I wanted to remind you once, because it's almost day 15, right? Almost half of the June daily Liquid challenge is over, and we are about to face the second half. So yeah, friend, that was all for today. See you tomorrow. Thanks a lot.